Okay, this podcast we will be configuring a Cisco router to support some DHCP and DNS stuff as a DHCP and DNS server. But first, we're going to configure it to have some IP addresses for inter-VLAN routing and for basic connectivity. So since we've done that before, I'm going to do it very quickly. And I thought it would be fun if while I was doing it very quickly, I talk like an auctioneer. So, no, I'm actually not going to do that. I did think it'd be fun. It'd be like, oh, you configure interface FA01. We got to go to interface FA01. 00, do a no shutdown. FA00, no shutdown. Can we get a no shutdown? I got a no shutdown. Then we need to do FA0. 0.2 to create the sub interface. When you guys set the encapsulation to VLAN 2.1Q, can I get a .1Q2 for VLAN 2? And then you set IP address on VLAN 2. VLAN 2 IP address is going to be 10.1.1.1 with a 25-bit mask, which would be 128. But anyway, I thought that'd be fun. And it was kind of fun for a while, but I'm kind of out of breath already. So, obviously, we've already done this like 1 trillion times, and I just screwed that up because that's not the sub interfaces I wanted to do. So, no int fa0/0.2. I want to do that on 01. So int fa00 is going to get an IP address. Oops. It's going to get an IP address from the hack network. So we will do IP address DHCP. So that is how we tell the router we want it to get an IP address from DHCP. We haven't done that before, but that's what we're doing right now. It's probably a pretty common thing you might run into if you're getting addresses from Comcast or somewhere. They like to use DHCP for stuff. So now we're going to do FA01. FA01, no shutdown on the physical, create some subs, do the encapsulation, .1Q2, get an IP address. I actually told you what IP addresses to use this time. Shocking, right? And then we'll do a sub interface for VLAN 3. Give it an IP address. Oh, darn it. Forgot to do that. Now we can give it an IP address. Exit. So right now I have an IP address on my router, and I have my IP address from the college. If I do show IP int brief, we look at that. I got 172.23, 164.118 from the college. I have 2 sub interfaces with addresses set. And if I do show IP route, I should hopefully have a default gateway that I got from college. So here it says I have a gateway of last resort, which is that from the college. You may have issues if you connected your router to the network and then turned your router on after it was connected. You may have gotten an IP address from the college, but you may not have gotten the default gateway. So if you're having issues and you have an IP address, check to see if you have a default gateway. So I've switched over to my switch because I need to set some VLANs. I have connected, I need to put one port in VLAN 2. So I'll put switch port access VLAN 2. I'll put port 2 in VLAN 2, and I want to put 2 ports in VLAN 3. So I'll put 3 and 4 in VLAN 3. 4 VLAN, oh, that was right, VLAN 3. And that's all I need to do on the switch. Oh, that's not all I need to do on the switch. I also need to set a port for trunking. And that was what I need to do on the switch. So if I look at my VLANs, show VLAN brief, I have VLAN 2, VLAN 3, and 24 is trunk. It's a trunk interface. There we go, trunking, perfect. So now I'll go back to my router. So we are going to configure our router to give out some IP addresses via DHCP. In order to do that, we create a DHCP pool. We specify the network we're on. We specify what the router should be, and then we give it a DNS server. So let me step back for a minute. At the top of the lab, you will see some words in big letters that says be very careful, blah, 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 blah. Basically, that's saying that if you accidentally start giving out addresses to the hack network, you will lose some points for the lab. So make sure that you connect and configure things very carefully and that you are not giving out IP addresses to our other users, because that makes us look bad, and I don't like looking bad. So we're going to create a DHCP pool. This is the command, and then you put whatever you want in for the pool name. You know, I suggest something that makes sense, like VLAN to DHCP or VLAN 2 pool, and hit enter. It did not like that because I didn't type conf t first. Awesomely, DHCP pool, VLAN 2 pool. Right now, you tell it what the network is. In this case, we have VLAN 2 be the 10.1.1.0 network with a 25-bit mask. So we put that subnet mask. Then we tell it what the router is. Default router 10.1.1.1. This is the router interface on that VLAN. So you saw me set the sub interface for that. 10.1.1.1. And then 4 things we need to get out to a net to participate in a network usefully. We need an IP address. So it's going to assign us an IP address out of this range with this prefix length or net mask. We need a router. What's the other thing we need? Oh, that's right, a DNS server. Thanks, everyone, for playing along. And at this point, we're going to put the hack DNS server in as our DNS server. And this right here will give us a good working DHCP configuration. However, there's one more thing we're going to put in just to get a full config so you understand other things you might need to do. This is where we can tell our router not to give out some addresses. Right? Why might we want to tell it not to give out some addresses? Well, we might have some servers that we want to configure statically. So we want to save some address space in our subnet to keep our router from giving out all the addresses. So that way we can have server addresses. So that's pretty much it for the config. If you look at the config once you're done, there it shows up. The pool shows up. Then you have the excluded addresses part shows up outside the pool. I'm not exactly why they do it that way. Doesn't really make a lot of sense to me. But anyway, we have our Windows machine here. And we will do ipconfig and see what it looks like. I didn't connect the cable yet, so that might help. I'm going to go ahead and connect the network cable. And hopefully once spanning tree is done doing its fun stuff for 50 seconds, then we will be able to get an IP address from our DHCP server. Fun time. So I'm waiting about 50 seconds for fun. I thought I had Wireshark on this guy, but apparently I don't. So, alright. I guess we won't look at the packets. Media disconnected. It's a VM, so I need to check my settings. Oh, I didn't want to check that setting. Up here I got a network setting that's not connected. So I'm going to connect it. And now, hopefully, it won't say media disconnected. Hey, look at that. I got a hack address. That's no good. I guess I need to... Alright, maybe that's my old address I had before. So with the DHCP IP, obviously on Windows, ipconfig releases your address. ipconfig renews your address. I was trying to do this on a VM so that... Oh, I know what the problem is. I plugged into the wrong VLAN. I'll be right back. Let me go change the VLAN I plugged into. Alright, when I connected the cable to the switch, I was planning for the second part of the lab already. which we're not there yet. So hopefully this thing will get an IP address and we can move on and finish up. Oh, and there we go. I have an IP address from my router. It gave me 10.1.1.52. I got a gateway of 10.1.1.1. If I run ipconfig/all, you can see that I have a DNS server on there. So the next step in the lab says try to connect to the internet. So we're going to try to connect to the internet. We're going to type www.google.com. And we're going to wait for a while. And it's going to fail. And we're like, oh no, why did it fail? I don't know why it failed. And we're going to sit there and think about it for a while. And we're going to try to figure it out. And we're going to ask Rich. And Rich is going to walk over and he's going to grab the lab sheet and turn it over. And it's going to say, it didn't work because you need NAT. Network address translation. We have private addresses that we're using. The hack network does not know where our private addresses live. It doesn't know anything about our 10.1.1 addresses. So the traffic is not making it back to us. So we need to configure our router for NAT, network address translation. This is where we tell our router to, hey, any traffic that matches this particular address, I want you to translate it to look like some other address. So first thing we need to do is configure the interfaces to mark them as inside or outside, because your router has no concept of inside or outside. So we need to configure the interfaces so the router knows which interface it should consider inside and which one it should consider outside. I gave you the commands and the sheet. So FA00 will be outside. FA01.2 in this particular instance will be inside. I'm going to go ahead and do 1.3 so later on I don't look foolish for not remembering to do it. That will also be considered an inside interface. Then we need to create an access list. Just type these words in without worrying about what it's doing right now because we haven't learned about access lists. But essentially this is a standard access list that is going to match our packets and NAT them as needed. Backwards. And this is a wildcard mask that we need for that. And then we need to do a ipnat command. ipnat inside source list 1 interface FA0/0 overload. So basically we're doing network address translation, port address translation. So we're actually translating ports. So we look at what we put in here. We identified the interfaces as inside or outside. I created this access list to match anything that starts with 10.1.1. So that would take care of both of our VLANs. If I wanted, I could have created an access list with 2 entries with different wildcard masks, but this just covers both of them, so we'll worry about that. We won't worry about that right now. And then this command here actually did the NAT. So it said pretty much anything that comes in the inside interface that matches list 1, I want you to NAT it to be the IP address of FA00, and the overload keyword enables the PAT part that allows us to have multiple clients use that. So let's try Google again. Hey, it worked. So that's the basic DHCP stuff. I'm sure on the router, I probably shouldn't do this because I don't know what the answer is, but I'm sure somewhere on the router we can see which clients have which IP addresses. So yeah, so hey, on the router, I can run the command show IP DHCP binding to see that, oh, I gave out 10.1.1.51 to this MAC address, and I gave out 10.1.1.52 to this MAC address. So that's pretty cool. So that's it for the DHCP server on the router. DHCP on the router. So now I want to configure my router as a basic DNS server. Basic DNS server, and you can do that with a few commands. First off, you want to set the name server on the router. These are commands are what we're going to be doing. Set conf t. Almost did it again. That's pretty cool. You guys like that sound? It's like a big bongo drum or something. Anyway, we're going to set the name server. This is going to be the server that the hack DNS that our router asks DNS questions to that it doesn't know. So what we're going to be doing is we're going to be asking our router some questions, and if it doesn't know the answer, we want it to ask some other name server. So we need to set the DNS server to be the hack DNS server in this case. So our router is going to ask the hack DNS server any questions it doesn't know the answer to, which the hack DNS server is that. I'm pretty sure I told you that earlier. Yeah, 100.5. Then we're going to tell our router we want it to be a DNS server. It's like, hey, yo, you are now a DNS server. And it's like, cool, I've always wanted to serve DNSs. And then we're going to create a 1A record, IP, name, IP host, and we're going to syntax for this. We're going to call it rich1. And then we're going to put the IP address of the host, which just for fun for now, we'll just make up an address. You know, that's an address in my network. And that'll be that. So the other thing we want to, well, first let's go see if it works. In theory, I use the NSLOOKUP command. I can set my server to 10.1.1.1, which is my DNS server, and now I can ask it about rich1. And it told me the answer. So now my DNS server, my router is configured as a DNS server to serve answers back to my PC. And it should also be able to ask the hack server about Google, and then it should be able to return those responses back to me. So I just asked my router what the IP address for Google was, and it told me the answers. So that proves that it's getting back out to the hack servers for DNS. So then the next thing that follows is if now our router is our DNS server, we should change our DHCP config to tell our PCs to use our router for the DNS server. So we're going to go back to the router, right? We're going to go into the DHCP pool. I'm going to do a show run so I can see what I need to change because I can't remember. So we'll go into the DHCP pool, IP DHCP pool, VLAN 2-pool, and then we'll do this two different ways. First, we'll do DNS server and put the new one in. All right, and now we'll look at our running config. Do show run. That's not contiguous. Ambiguous. That's weird. Try that again. Do show run. Weird. And we'll look and we'll say, okay, it did overwrite the DNS server. I was afraid it was going to leave the old one in there and not overwrite it. So now if we do IP config release renew, release renew, renew. And we see that now we have, oops, I don't see anything yet. We see that now our DNS server is 10.1.1.1. So we should also be able to get out to the internet to some other website, and it should also work. What? Web page is not available. That's no good. Oh, maybe ESPN is not a secure site. Maybe they don't even listen on 443. Oh man, I'm glad I figured that out. I hate it when I do something I can't figure out. So anyway, now I can get out to the ESPN.com page. So we basically configured our router as a DHCP server, and then we configured our router as a name server, and then we configured our router, our DHCP pool to use our router as a name server and to get us out to the internet. So now we are doing all that.